Aetosaurs were a successful group of heavily armored reptiles which were protected by numerous bony plates called osteoderms. Although they resembled the similarly heavily armored and more famous ankylosaurian dinosaurs, Aetosaurs were not closely related to them, nor were they even dinosaurs. They instead belonged to the clade Pseudotsuchia, meaning they shared a more recent common ancestor with crocodilians than with dinosaurs. All Aetosaurs lived during the Triassic period, a time when Pseudotsuchians were the dominant large animals, and most of their dinosaurian cousins were still small. The largest of these tank crocs was the unusual, wide-bodied Typothorax. Its fossils are from the well-studied Chinle Formation and other contemporaneous geological formations in the southwestern United States. Typothorax is one of the best understood aetosaurs, but this was not always the case. Most of its fossils are fragmentary, and even its basic appearance was a mystery until fairly recently. Typothorax was first described in 1875 by paleontologist Edward Drinker Cope, and it has the distinction of being the second aetosaur to be officially named. Cope based the Typothorax genus on nothing more than a few osteoderms, perhaps out of a desire to name more new species than his rival, paleontologist Othniel Charles Marsh. The feud between these two scientists is so infamous that it is called the Bone Wars, and over the years, many of the species they named have been found to be synonyms of other, previously named species or to have been based on undiagnostic material. Fortunately, it turned out that the shape of aetosaur osteoderms is unique to each species, so they are therefore genuinely diagnostic, but it took nearly a century after Cope's initial description for paleontologists to have an even vaguely correct picture of what Typothorax looked like. While other Typothorax fossils were found over the years, they still mostly consisted of osteoderms, and very few skeletal fossils belonging to other aetosaurs were found during the following century to fill in the gaps. Worse, paleontologists had mistakenly assigned bones belonging to phytosaurs to the clade. Phytosaurs were semi-aquatic predators which, despite appearances, were actually more distantly related to crocodilians than Typothorax was. The misconception that aetosaurs were crocodile-like creatures didn't change until 1961, when the description of newly discovered skeletons of the Aetosaur stagonolepis proved they were instead terrestrial and predominantly herbivorous animals. Other well-preserved aetosaur skeletons were found over the next half-century, but none of them belonged to Typothorax, or even to its branch of Aetosauria, Typothoracinae. For decades, depictions of Typothorax were simply generic aetosaurs drawn with a wide body and its unique osteoderms. This finally changed in 2010, following the description of not one, but two nearly complete articulated Typothorax skeletons. While the bones on the bottom of one of the skeletons, nicknamed the Badlands Ranch specimen, are clearly visible, much of the top armor is missing. This is hypothesized to be the result of scavenging before fossilization. Large portions of the matrix above the Badlands Ranch specimen had to be left unprepared to keep the skeleton together. It is unfortunate that such caution was not applied to the other, previously more complete Typothorax skeleton referred to as the Revuelto Creek specimen. This exceptional fossil was accidentally damaged during an attempt to make casts. Even the photographs used in the official description shown here are of those casts rather than the actual fossils. Still, these skeletons, combined with a recently discovered skull, have filled in essentially all of the gaps in the anatomy of this long-extinct Pseudotsuchian. As previously inferred from the shape of its osteoderms, Typothorax's body was significantly wider than those of most other aetosaurs. However, the front of its torso was much narrower than expected. The resulting appearance is so strange that the paleontologists who studied the skeletons said that if they had not been found in articulation, it would have been assumed the front halves came from separate, younger individuals. The complete Typothorax skeletons are only 2.5 meters long. Since none of the other Typothorax fossils available at the time they were described were much larger than the corresponding elements in these specimens, it was thought this was the upper limit of Typothorax's size. Science's view of Typothorax changed yet again in 2023, which saw the description of a massive Typothorax specimen. While incomplete, comparisons with other Typothorax skeletons determined it had been over 5 meters long, exceeding the size of Desmatosuchus, the previously largest known aetosaur. Furthermore, Examination of the growth rings in the giant Typothorax's ribs found it was still growing when it died, and the sutures of its trunk vertebrae hadn't ossified as in adult Aetosaurs. On the other hand, the vertebrae of the smaller, 2.5-meter skeletons had ossified, meaning they had already reached their full body size. This extreme size difference could have been the result of extreme sexual dimorphism. Alternatively, since the giant Typothorax specimen is incomplete, it could represent a new, distinct species of Typothorax. Such dramatic size differences within a genus may seem unusual, but they are no greater than those exhibited by the Chinese and American alligators of today. However, the explanation favored by the authors of the paper which described the new material is that the extreme size differences were the result of developmental plasticity, a strategy employed by many Triassic dinosaurs, including Plateosaurus and Coelophysis. These dinosaurs had the ability to halt their growth during the frequently harsh droughts of the Triassic world. While a series of bad years would mean that many of the survivors were far smaller than their maximum body size, and therefore more vulnerable to carnivores, it was better than starving to death. Given the close relationship between dinosaurs and pseudosuchians, it is possible that Typothorax employed a similar strategy. While prominent among the Aetosaurs, osteoderm armor was common in most pseudosuchians and can still be found in the Crocodilians of today. While the arrangement varied, most extinct pseudosuchians had a pair of osteoderms over each of their vertebrae, starting from their neck to the middle of the tail. Called the paramedian osteoderms, they had widened dramatically in the tank crocs, with Typothorax representing a particularly extreme example. In most other pseudosuchians, the paramedian osteoderms were typically arranged with one pair corresponding to each vertebra. Typothorax's anterior paramedian osteoderms instead covered multiple vertebrae. This is because when its torso became shorter than those of other Aetosaurs, this was partially accomplished by shrinking the size of its vertebrae. The osteoderms remained about the same size, instead shrinking in number. It has been proposed that this may have been accomplished by a mutation in a Hox gene deleting some of the rows of its armor. Before its unique armor arrangement was discovered, the assumption that Typothorax's osteoderm pairs were 1-to-1 with each vertebrae led to overestimates of the size of the then largest known specimens, which, ironically, still fell short of the newly discovered, record-breaking skeleton. Beyond enhancing the paramedian osteoderms they inherited from their ancestors, Aetosaurs added numerous additional osteoderms which came in a varied number of shapes. Among those found in Typothorax were spikes positioned along the edges of its paramedian osteoderms. This ensured that attacks directed against them wouldn't merely be ineffective, but had the potential to outright harm the attacker. The third pair of spikes on the neck were much longer and slenderer, which presumably provided greater protection to what was the most vulnerable location on Typothorax's body. It has been suggested that these were homologous with the large shoulder spikes found on the Aetosaur Desmatosuchus, which grew nearly half a meter long. Since they are the fifth pair of spikes in Desmatosuchus, it seems that Typothorax lost the even rows of osteoderms when its torso shrank in size. The osteoderms on top of Typothorax's tail can be seen as a combination of the previous two shapes, matching the pattern of the preceding rows on the back, but forming backwards pointing spikes. They would have not only deterred attacks from behind, but also increased the effectiveness of its tail as an offensive weapon, both against predators and rival Typothorax. A close relative of the Aetosaurs, Revueltosaurus, took this a step further, developing a club at the end of its tail roughly 100 million years before ankylosaurid dinosaurs did the same. Typothorax's armor extended to the underside of its tail, with an empty space where its cloaca would have been. Typothorax is unique among Aetosaurs in that the osteoderms surrounding the cloaca consisted of large spikes. They could have been used to thwart predators attempting to lunge from below, which would be particularly helpful since Typothorax's armor on the underside of its tail was otherwise reduced when compared to that of other Aetosaurs. However, their primary purpose was likely as a prehistoric version of a chastity belt. In any event, it is clear this tank croc would have needed to have been very careful when mating. The armor on Typothorax's belly did not mirror the paramedian osteoderms. Instead of two widened plates, each row instead consisted of numerous small osteoderms. Those protecting the limbs were even smaller. Its forelimbs were much shorter than its hind limbs, So even without its armor or rotund body, Typothorax would not have been particularly fast. Typothorax's forelimbs were also held in a semi-sprawling posture, comparable to the posture seen in modern crocodilians. This was actually an evolutionary reversal, as Pseudotsuchians ancestrally had fully upright, dinosaur-like limbs, a condition retained in Typothorax's hind limbs. It also happened to converge upon a different dinosaurian trait. While the ankles of most Pseudotsuchians had a flexible arrangement called the crocodile normal ankle, the ankles of Typothorax's hind limbs were similar to the simpler, hinge-like ankles of dinosaurs and pterosaurs. It is hypothesized that the tank crocs often dug in search of roots, and the sturdier, dinosaur-like ankles of Typothorax were well suited for this lifestyle. The wide-bodied Aetosaur's legs possessed numerous other traits typical of diggers, including a humerus which was powerfully built and proportionally long relative to the rest of the forelimb, foot bones which were short and wide, and its hind limbs possessed large claws. Typothorax was far from a reptilian mole, but it was the herbivore best suited to dig for roots in late Triassic North America. The discovery of the two almost complete Typothorax specimens helped to solve a long-standing mystery in paleontology. For years, a type of fossilized footprint called Brachychirotherium had been found in late Triassic formations across the world. It had been suspected that these footprints had been made by Aetosaurs, but Typothorax was the first Aetosaur found with feet complete enough to prove it. This has in turn revealed much about how it and other Aetosaurs walked. Based on these tracks, it appears that the front feet were plantigrade, meaning they walked with the foot bones flat on the ground, while the hind feet were semi-plantigrade, meaning they partially walked on their toes. The difference in foot posture was likely a result of Typothorax's hybrid stance. While all Aetosaurs had small heads, Typothorax's skull was small even by their standards, adding to its already peculiar visage. Its skull was also shorter and more gracile than the skulls of most other Aetosaurs. The closely related Aetosaur Paratypothorax had a similar skull, but before the description of a complete Typothorax skull in 2021, it was thought the comparatively robust shape seen in Desmatosuchus was the norm among Aetosauria. It was also assumed Typothorax had the wide, flat, shovel-shaped snout that many other Aetosaurs used to dig through the dirt, but it turned out that its snout instead tapered into a thin, narrow tip, just like in Paratypothorax. As this was discovered just a few years ago, it is unfortunately not reflected in much of the otherwise accurate paleoart depicting Typothorax. While Typothorax and Paratypothorax are the only Typothoracines with preserved skulls, it is hypothesized that their more gracile skull morphology was the norm among Typothoracinae. Their fragile composition meant they would have been far less likely to be fossilized and remain articulated than the more robust skulls of other Aetosaurs, explaining the scarcity of cranial material belonging to what was a fairly sizable Aetosaurian subclade. Unlike other Aetosaurs, even Paratypothorax, Typothorax's snout was upturned. The paleontologists who described the skull didn't consider this an adaptation for digging due to its gracile shape, but it is conceivable that it helped the giant Pseudotsuchian to sort through the loose soil already dug up by its claws. Typothorax's nares were significantly smaller than those of other Aetosaurs, which suggest a weaker sense of smell. Typothorax's teeth were also the most varied of any Aetosaur. The majority of them have a round, leaf-like shape and are lined with denticles. Such teeth are typical of herbivores, but one pair in the dentary lacks these denticles and is recurved. The teeth in the premaxilla are not only recurved, but thin and sharp, which resembles the dentition of meat eaters. The Aetosaur Aetosauroides is actually thought to have been a carnivore, but unlike this species, none of Typothorax's teeth have serrations. Combined with its more abundant leaf-shaped teeth, this wide-bodied Aetosaur was likely an omnivore, which primarily consumed vegetation such as ferns and roots, but also opportunistically ate the invertebrates it dug up with them. Although the 5-meter-long specimen may represent a new species, as of right now, all Typothorax fossils are assigned to a single taxon, Typothorax coccinerum. Some fossils had previously been assigned to a second species, Typothorax antiquum, but they are now thought to merely represent Typothorax coccinerum adolescens. Their osteoderms are shorter and narrower, which suggests they had correspondingly narrower torsos. Additionally, the limbs of adolescents were more elongate, which implies they were able to run faster than the adults. This makes sense, since they were still too small to face most carnivores head-on. Typothorax may have lived in large groups, at least during their early years. A large assemblage in Germany contains the skeletons of 24 young aetosaurs, which died together. All of them belong to Aetosauria's namesake, Aetosaurus, and examination of their bone histology found they were all less than a year old when they died. Although paleontologists have yet to discover fossils of Typothorax this young, Aetosaurus might be a very close match in spite of its slender body. Aetosaurus was traditionally classified as a basal aetosaur, but this was because it was only known from meter-long juveniles, causing it to cluster with other immature aetosaur specimens in cladistic analyses. It is now thought Aetosaurus was a juvenile Typothoracine, and Typothorax's close relative, Paratypothorax, may even be its adult form. If so, then Typothorax's famously wide torso was entirely absent when it first hatched. It would have taken them some time to reach their full size. Examination of the bone histology of the ribs belonging to the giant Typothorax skeleton determined that even though it wasn't fully grown, it was already between 15 to 20 years old when it died. Dinosaurs were able to grow considerably faster than this due to their higher endothermic metabolisms. That said, Typothorax was still able to grow faster than today's crocodilians, as Pseudotsuchians originally had an intermediate metabolism between that of the traditionally ectothermic reptiles and their dinosaurian cousins. Given how long it took them to reach adulthood, it can be inferred that those Typothorax who had reached their full size were largely safe from predators. While not impossible to take down, they were some of the, if not the, most daunting prey in their environment. Science's understanding of Typothorax has come a very long way since the days of Edward Drinker Cope, from a few pieces of armor thought to belong to an ancient crocodile to it being one of the best understood megafaunal plant eaters of the entire Triassic period. Even after the nearly complete skeletons were found, the image of what this Pseudotsuchian looked like has been continuously updated by new discoveries. This includes the well-preserved skull, insights into its lifestyle, and the recent specimen that proved it was the largest known member of the tank crocs.
Thank you for watching, and a thank you to themattalorian for narrating this video. If you enjoyed it, please remember to hit the like button, and subscribe if you'd like to see more. Finally, be sure to have a great day.